students, welcome to Easy BTech, your guide for BTech and beyond. Easy BTech helps you to understand the concepts of engineering subjects very well, and also you can prepare well and write the examinations. This also helps the students for various competitive examinations and also placement drives. So in the previous video, we discussed about the parallelogram law of forces and a problem. And in this video, we solve two more problems. So the problem is given here. The resultant of two forces, one of which is 3 times, the other is 300 newtons. When the direction of the smaller force is reversed, the resultant is 200 newtons. Determine the two forces and the angle between them. So when two forces and the angle between them is there, it is related to the parallelogram law of forces. So solution is, first you write the given data. So here the case 1 is, let us say there are two forces P1 and Q1. There are two forces are there, and one of which is 3 times the other. So let us say P1 is equal to 3 Q1. P1 is equal to 3 Q1. So when the direction of the smaller force is reversed, the resultant is 200 newtons. In this case, this R1 value is 300 newtons. This is case 1. And in the second case, let us say you take the two forces P2 and Q2. And P2, there is no change in the P2. So P2 is nothing but P1 only. There is no change. But when it comes to the Q2, the direction of the force is changed. Okay, that means the Q2 becomes minus Q2. So minus Q1. Minus Q1. So this is the only change. So this is case 1 and this one is a case 2. The smaller force is changed here. So here this the P1 is greater than Q1. So in such a case, the R value is 200 newtons. 200 newtons. And now find out what is P1 and what is this Q1 and what is the angle between these two things. So this is the problem. So when you take in the first case, so here, so this one is R2, and here this R1 is equal to, so P1 square plus Q1 square plus 2P1 Q1 cos theta. So this is the formula. Here the P1 is nothing but 3Q1 square plus Q1 square plus 2 into 3 Q1 into Q1 cos theta. So now, so with this R1, so it comes to, so here this R1 value comes as so root over 10 Q1 square plus 6 Q1 square cos theta. So R1 value is 300 newtons. So this one is 300 newtons. So here 300 is equal to 10 q1 square plus 6 q1 square cos theta. So if you square on both sides here, so this comes to the 90,000 is equal to 10 q1 square plus 6 q1 square cos theta. Let us say this is the equation 1. And when it comes to R2 here, so here R2 is similar. So when we are talking about the R2, so here this is P2 is same as P1. So this is again P1 square plus Q1. The direction is changed here. The Q2 has become minus Q1. So minus Q1 square plus 2 into P1 minus Q1 cos theta. So the R2 value becomes 200 newtons because of this change. So now R2 value is 200 is equal to root over, so the P1 is 3Q1 square, so this becomes 9Q1 square, and so this is again the Q1 square minus 2 P1 Q1 cos theta. This is what you get. So on squaring both sides, you get 40,000. So this is equal to 10 Q1 square minus 2 P1 Q1 cos theta. Let us say this equation is 2. So we have taken the case 1 and case 2. In the case 2, only thing that is changed here is the direction of the second force is changed. So we got two equations here. So by using these two things, so in this case, if you're taken the 1 and 2, so if you add 1 plus 2, so add these two things here. So 1 and 2, so in this one, so the 2pq1 cos theta and 2p1q1 cos theta is nothing but 10q1 square minus p1 is 3q1, so it becomes 6q1 square cos theta. Okay, so this is 40,000. So when you're adding these two things here, so 6q1 square cos theta, okay, become cancelled, and now so we get 20q1 square. So this will become the 90,000 plus 40,000. So by this one, you can find the value of the q1 square here. So q1 square becomes q1 square. So this will become the 6,500. So from this one, the q is equal to 80.62 newtons. This is the q1 value. And once you get q1 value, the p value is equal to 3q1. And so this one is 241.86 newtons. 241.86 newtons. So by this we got the values of P1 and Q1, and by taking either equation 1 or 2, you can find out the cos theta. So that means you can select either equation 1 or 2. So in such a case, so if you have taken the first equation and substitute the value of Q1 over there, we get the value of cos theta. So the cos theta is equal to 0.021. The theta is equal to cos inverse 0.021. By this, the theta value can be calculated. So this comes to 88.7 degrees. 88.7 degrees. So we got both the values here. So finally it comes to what is the given force. P1 is 241.86 newtons, and the Q1 is 80.62 newtons, and theta is 88.7 degrees. So this is the final answer. So once again here we have taken both the cases. In the second case, the direction of the second one is reversed here. So we've taken both the resultants and we got two equations. On solving these two equations, we got the values of P1 and Q1, and you take one of the equations to substitute P1 and Q1, automatically you get the value of theta. So this is how it can be solved.